Final project number 1. Cross-Maltese Algebra Geometric Model. I am Vincent Joaquin Mamawag from BSED Math 3B. Final project number 1. Show that the set of moves in your geometric model forms a group structure. Cross-Maltese Algebra. The Maltese cross is a cross symbol with 4 B-shaped arms that come together at a central point, creating a distinctive 8-pointed shape. It is widely recognized as a symbol of a fire service representing courage, sacrifice, and protection, but also has roots in the Knights of Malta, a Catholic military order. Cross-Maltese Algebra moves. A stands for do nothing. L, move 45 degrees counterclockwise. G, stands for move 90 degrees counterclockwise. E stands for move 135 degree counterclockwise. B stands for move 180 degree counterclockwise. R stands for move 225 degrees counterclockwise. U stands for move 270 degrees counterclockwise. H stands for move 315 counterclockwise. 1. Flip vertically. 2 stands for flip between vertical axis and right diagonal. 3 stands for flip through right diagonal. 4 stands for flip between horizontal axis and right diagonal. 5 stands for flip horizontally. 6 stands for flip between horizontal axis and left diagonal. 7 stands for flip through left diagonal. 8 stands for flip between vertical axis and left diagonal. So these are the moves. So if we have A star A is equal A, B star L is equal R, G star R is equal to H, B star H is equal to E, U star 1 is equal to 7, 4 star 8 is equal to B, 2 star H is equal to 3, 1 star 2 is equal to H. Now we're going to show the set of moves in our geometric model forms a group structure. Group. A group G, set of G, close under the binary operation star such that the following conditions are satisfied. First, for all A, B, C is an element, we have A star B star C is equal to A star B star C. This is associativity of binary operation star. G2, there is an element of E in G such that for all E is an element of G, E star X is equal to X star E. This is the existence of the identity element E for star. Third, there is an element E in G such that for all E is an element G, there is an element A inverse in G such that A star A inverse is equal to A inverse star A is equal to E. This is an existence of inverse element for all elements of G. Now, this is the table of results. First condition, checking if it is close. Since the resulting elements were just found in the set A, L, G, E, B, R, U, H, 1, 2, 3, 4, 5, 6, 7, and 8, thus the geometric model is close. Second condition, checking for its associativity. To verify the associativity of this geometric model, we must rotate it into 180 degrees. Upon changing it rows and column, therefore, it is associative. Third condition, checking if identity element exists. To identify if there is an identity element existing, to identify if there is an identity element existing, we must find a row and column that matches the element in the outer row and column and look for the element where the row and column intersect. Okay. Therefore, upon finding the elements inside the table that matches the elements outside, A is the identity element E. Fourth and last condition. Checking if there's exists an inverse element for all. The identity element is A. To find the inverse, look for all the identity element in the table and highlight it. Now, the inverse element for each element is A inverse is equal to A, L inverse is equal to H, G inverse is equal to U, E inverse is equal to R, B inverse is equal to B, R inverse is equal to E, U inverse is equal to G, H inverse is equal to L, 1 inverse is equal to 1, 2 inverse is equal to 2, 3 inverse is equal to 3, 4 inverse is equal to 4, 5 inverse is equal to 3, 6 inverse is equal to 6, 7 inverse is equal to 7, and 8 inverse is equal to 8. Since there exists identity element for every row and column, that is A, thus it has inverse elements for all.